Okay, hi all. Just a quick video there to show you how to do this part of the homework last night. It was find term n for this sequence, which we'll find out in a minute turns out to be a quadratic sequence. So they're pretty much just 4 steps. The first step is find the second difference if it is a quadratic. So first difference first. 4 to 9 is going up by 5, 9 to 16 up by 7, 16 to 25 going up by 9, 25 to 36 is increasing by 11. Okay, that's the first difference. Second difference, going up by 2, going up by 2, 9 to 11 is going up by 2. So the second difference is constant, so it's definitely a quadratic sequence, and we've done the first step, we found the second difference. Okay. Since we've found the second difference to be constant, we know that it's a quadratic sequence, so we know the term n of a quadratic sequence is in this form: a n squared plus b n plus c, where a is some number we don't know yet, b is some number we don't know yet, and c is another number we don't know yet. However, step 2 is to take the constant, the second difference, the common second difference if you like, and divide it by 2, and that gives us our a value. So we can do the second step and say that term n is equal to 2 divided by 2 goes in once, so it's 1n squared plus bn plus c. So we have the first 2 steps done. We found the second difference, and we found the coefficient of n squared, which we worked out to be 1. Okay, so it's always half of whatever this is. Half of 2 is 1. Okay, the next step, the third step, is try to form 2 equations that have the letter b and the letter c in them. Okay, form 2 equations. And the way we do that is we take any of our terms from up here, and I usually start with the smallest terms because the numbers are small to deal with when we're adding and subtracting and multiplying and whatever else we might be doing. So term 1, this is the first term, is 4. Then I use as much of the formula as we already have to work out what term 1 is, even though I know the answer already. It's 4. But if I try and use the formula to work it out, I say T1 is equal to, and I sub 1 in wherever I see an n. So it's 1 times 1 to be squared, because there was an n there, plus b times, again 1, I'm subbing 1 in instead of n, plus c. And if I tidy that up a little bit, I still have term 1 is equal to, well, tidying this up, 1 squared is 1 times 1 is 1. B times 1 is just b, and plus c, can't do anything with that. Okay, then I say, well, I already know what term 1 is, so if term 1 over here is equal to 4, that means all of this 1 plus b plus c must work out to be 4 if I knew what b and c were. So I can say let 1 plus b plus c, which is this here, be equal to whatever term 1 is equal to, which is 4. And then I tidy that up a little bit more. I bring the 1 over to the other side, and maybe I'll just write this out fully. It becomes b plus c equal to 4 minus 1, because when the 1 goes across, I change the sign. And then lastly, you have b plus c equal to 4 take 1 is 3. Okay, that's half of the third step done. The second half is to find another equation like this one. Okay, and we took term 1 first of all to come up with that equation. Now we might take term 2 to come up with our next equation. So term 2 we know is equal to, up here, the second term, it's 9. And then if we were to use our whatever bit of a formula we have so far, our incomplete formula if you like, to work out what term 2 is, we would put in 2 wherever we saw an n. So that's 1 times 2 to be squared, plus b times 2 plus c. And then we could tidy that up a little bit. So 2 squared is 4 times 1 is just 4. B times 2, or 2 times b, is 2b. And c, well, we can't tidy that up anymore, it's just that. Okay, and then what we say again is, well, if we, this is as far as we can go in finding out what term 2 is, but we already know the answer. Term 2 is equal to 9. So all of this is going to turn out to be equal to 9. So we can just write that down. 4 plus 2b plus c is equal to 9. And then what we do is tidy up, and again I'll do it out fully here. We bring the 4 across to the other side, leaving the 2b plus c on the left hand side, leaving the 9 where it is. But when we bring the 4 across, what happens? It becomes a minus 4. So we're left with 2b plus c is equal to 5. And this is our second equation, linear equation with b and c in it. So we have two equations now. That's step 3 done. So step 1, find the second difference. Step 2, find the coefficient of n squared, which is half of this. So we just divide that by 2. Step 3 is find these two equations. And the last step, step 4, is do our solving simultaneously to solve simultaneously between these two equations to find the value of b and c. So again, I'll write down these two equations. 2b plus c equal to 5 and b plus c equal to 3. And how we solve simultaneously is we try to get something above and below that we can cancel, so they need to be same coefficient and a different sign. So we already have c has the same coefficient, it's 1c and 1c. This doesn't, that's 2b and 1b. So 1c and 1c, that's perfect. We just need them to have a different sign so they'll cancel. So we're allowed to change a sign as long as we change all of the signs. So if I want that to be a minus c, then I have to change this to a minus b and this to a minus 3. So then I just add the top and the bottom together. So 2b minus b, or 2b and minus b if you like, gives me 1b. Plus c and a minus c cancel each other out. 5 minus 3 is 2, and I've got my solution for b. The value of b is equal to 2. Okay, once I know what b is, I can find c by subbing the value for b into either one of these equations, doesn't matter which. So I'll use the b plus c equal to 3 because they're smaller numbers there. Putting in 2 instead of the b because I know that b is equal to 2. I get this, and then I have c is equal to 3, bringing the 2 over, minus 2. So then c is equal to 1. So now I have my value for b, I have my value for c. All that's left is to write out the actual term n for this, this quadratic sequence, and it's Tn equal to, we already had the 1n squared, and again you don't have to put in the 1 if you don't want to. B is equal to 2, so we put the 2 in instead of the b, plus 2, oops, that's a horrible 2, 2n, plus we know that c is equal to 1, so we put in plus 1 here. And that's it. That's term n for that quadratic sequence. Now, if we wanted to double check though, if we had time, we'd go back and try one of these, like find term 3 or term 4 or term 5. Let's go for term 5 and see what it turns out to be. So using my term n that I have here, let's find out if term 5 is equal to 36 like it says it is above. So it's 1 times 5 to be squared. I'm subbing in 5 wherever I see n. Plus 2 times 5 plus 1, which is equal to 5 5s are 25, isn't it? Times 1 is just 25. 2 5s are 10. If I add all that together, 25, 35, 36. And that's exactly what term 5 is up here. 1, 2, 3, 4, 5. So we're happy with that.